Hello and welcome, everybody. Thank you for coming to the San Antonio Cloud Computing Group meetup for May 10th, 2021. I'd like to welcome everybody from the .NET virtual group as well. I'd like to thank the .NET Foundation for hosting this event, and I'd like to appreciate them for the work they do in bringing assistance, help, and education to developers. I think it's a great thing to do anything and do it for free and do it for the betterment of the community. And I just think they're a great organization. I'd like to thank Jeremy Sinclair for running the stream, running everything in the background. We got one event before we hand it over to Sean, and that's the announcement for next week. We're going to have Mark Brown, the principal product manager for Azure Cosmos DB. He'll be with us to discuss modeling and partitioning in Cosmos DB, and it should be a great introduction to developing using a distributed NoSQL database. I'm going to put that link in the chat here. Go ahead and put that in there. Okay, we'll go ahead and get to our main event of the evening. I'd like to introduce our guest, Sean Whitesell. Sean is a Microsoft MVP, a cloud architect, and the president of the Tulsa Developers Association. I've had a chance to code along with Sean and do listen to some talks with him, and you guys, everybody's in for a treat. I think he's honestly fantastic. I'll go ahead and link the Tulsa User Group in the chat, and I will link Code with Sean, which is Sean's Twitch channel, in the chat as well, where I myself am a subscriber and follower, and he does lots of great stuff over there as well. So without any further ado, I'm handing it over to Sean.
Thank you, Kellen. I really appreciate that. Thank you for having me this evening. I appreciate it. So we're going to be talking a lot about microservices, and specifically why I titled this the way I did, with the easy way is the wrong way. So we're going to talk about first getting started with the goals of talking about a microservices architecture, that it takes a lot more consideration than you would expect, meaning that there is quite a bit more to just doing microservices than the hype, right? Than the buzzwords. So there's just quite a bit more to it. So a quick agenda is we're going to talk about what microservices are, why should you use them, and when should you not use them, as well as a lot of the challenges that you will come across when developing microservices. We'll also do a quick and high-level talk about a decomposition using domain-driven design, but it's going to have to be really high level. We're going to have to skim the surface a little bit, because that topic in itself is so deep. We could do a workshop a week long just on that alone. So there's just so much to that. So normally when I'm in front of an audience pre-COVID, I would ask, so what are microservices? And I'd get a few answers from the audience. And that was kind of the point, and also highlighting the problem, is that there is not just one good answer as to what microservices are. Now, at least at the time, I really also did not have one to provide, but I'm going to try to do my best of a version of an answer. And that is that a microservice is simply a tiny monolith with a tight focus on a domain. It's not about the size of the code. It's not about how many lines of code or things like that. It's about the focus. Meaning that a microservice is meant to do one thing and do that one thing well. It's kind of like a monolith, where it's going to have its code. It'll have a database backend if it needs to persist data. But the point is, it's going to have a tight focus on a domain. We'll also talk about that a little bit later. And that domain is simply the business capabilities and features that it's trying to provide. There's also several main tenets about microservices. And the one that I'm going to repeat many, many times throughout this talk is that microservices are independent applications. They need all the love and attention as any other application that we develop. And instead of just being something that we instantiate in memory, microservices communicate over a network. Now, that might be direct connection using REST, or it might be using messaging. But the idea is that it's not simply an in-memory call. And microservices have a single responsibility. They're a service and they need to provide one service well. What is that one thing it does well? Simply meaning that if you have a microservice to process invoices, it should not also be handling forms for human resources. Those are two separate domains entirely. So have a microservice that is sized and scaled to what it needs for that business domain, that focus. And you may even see later that if you have a microservice that is just doing so much with accounts payable versus accounts receivable, let alone other accounting functions, you might even split those apart into their own microservices. And you'll see those pain points as they grow, and you have to decide when it's time to split that out. And microservices are owned by one team of developers. You should never have a microservice that is owned and developed and maintained by more than one team. You'll have so much contention on the way to do the development, deadlines, the whole growth of that microservice, etc. Now, a team can have multiple microservices, but as long as they're not shared across multiple teams. And microservices should be individually deployable, meaning that there should not be a tight coupling between one microservice to another. Now, they might communicate with each other because of business features, but that's more of a loose coupling. If you require every change of a microservice to also have the other microservice to go right along with it, that's getting very tightly coupled. You've got to be staying away from that. And moreover, microservices is an architecture style. It is less about code and more about how things communicate to work together to fulfill its needs as an architecture. Now, I know a lot of us have dealt with monoliths for a long time, and we say, okay, well, what's really a monolith? Simply, a monolith is one code base. It's got multiple independent functionalities. So maybe that is that one system that both handles HR, human resources type functionality, as well as invoices and accounting and etc. That's okay. Monoliths are not bad in and of themselves. And we'll talk a little bit more about this later, but when that monolith becomes a big problem, that's when you might decide to go ahead and pull a collection of business functionality, right? So maybe that's accounting, and maybe we extract that out to its own microservice. Another example is when you might create a microservice is when you need to add functionality that's new, but not bring it into the monolith. You might adjust that monolith so that it's contacting that new microservice with that new business functionality, maybe that new feature that you're offering, but it will not be in that monolith. And rarely will you have a total migration from a monolith to a microservices only architecture. Now, it has been done. It's been done several times, but not without its pains and not without its issues. And we'll be talking a lot about that here in just a little bit. And another big reason for microservices is that they are there to share and distribute that computational needs across other systems, across other servers. And the picture here is just to depict, maybe I've got 5 different microservices with multiple instances of them, depending on the needs, and then calling each other. The idea is that you want to spread the computational needs across multiple instances, spread across multiple servers. So why should you ever use a microservice? Coming back to that monolith, what if that monolith has grown, as they all do, year after year? There's always those code changes that occur. And after those code changes have occurred, maybe bug fixes, whatever patching that had to be done, you end up in what's called that big ball of mud or spaghetti code, where it becomes more and more fragile to make code changes. Now, if you're not in that position, you'll probably still be better off to use monoliths. But if you're in a position where the company you're working for is, they've got a new functionality that they need to get developed, and time to market is a big issue, because certainly if you're the first one in that market, then you get a lot more of that market share, right? That crunch time where the bosses are coming to you and saying that we've got this new feature, we've got to get this integrated, and you're like, well, it's going to be at least 6 months to adapt it into the monolith and fix the fragility that's already there, then you're not ready for that. You need to consider microservices. That's when you can make the tiniest changes to the monolith so that it can call and communicate with that microservice. So the idea is to help deliver business functionality quicker and safer and with more stability. There's also some really great other tenets that microservices provide, one of which is team autonomy. An example scenario of this is one that I've worked on where the main code base was all done in C#, but they also needed to bring in a lot of the functionality brought in by the data analytics team. So they were going to develop what is essentially the microservices, but they were going to do it in Python. Although C# can do data analytics, Python is just better suited for that. So it allowed the team to use the best programming language for the job at hand. As well, that team of developers was able to focus on those pieces of what was needed to be developed in Python, with a little bit of caring as what the communication was between the C# program and how it was getting data to and controlling the actions of the data analytics microservices. And if you already have a environment where you're using Agile, maybe Kanban, that works very well with microservices. And microservices provide service autonomy. This goes back to that single responsibility I mentioned earlier. It allows that microservice to be focused on one domain. If it's to process a paycheck or accounts receivable, accounts payable, things like that, it can be just enough size to focus on that domain. But it should not also handle many other domains, and because you're going to end up with a lot of contention. And there's hence the next item is that deployable without other services. So if we have too much going on, and we've got a microservice that is sharing code and is tightly connected to another microservice, then every time when you deploy one, you have to require the other service to be deployed as well. What if that other service is managed by another team of developers? Now you have a fight for deadline. So given the fact that microservices are independent applications, they should also be able to be deployable independent of other applications. And microservices can scale independent of other applications. The idea here is that if, depending on the type of workload that it's going to do, maybe I need more instances of one microservice versus another microservice. As well, what kind of servers are you going to put them on? Maybe it's Kubernetes, but even if it is, how much RAM do you devote? How much CPU do you help allocate for that? And are you going to put this in Azure? Are you going to put AWS, etc., right? It allows you the opportunity to have that choice of the servers and then instances thereof. Now, there's a lot more to this, and we'll discuss this a little bit more when we talk about networking. So how we communicate with microservices is also a big deal. And microservices provide fault isolation. The idea here is that if you take the example of Amazon and you go up to pull up an item on Amazon, you see the pictures, the description, you're able to pick out the item that you want, you put it in your cart and you purchase it. Fantastic. That's great. What if a microservice that's providing the reviews is unavailable for whatever reason? Maybe there was a bug in the code and it wasn't there. In that business flow, the review microservice did not stop that flow of activity for that user. Or maybe that you've got a payment system, payment microservice that happens to have an issue right at that time, but it's not stopping the user from still searching for items and putting them in their cart. And at least they'll be able to look around and find out what they need. And I mentioned earlier that there are companies that have done a total migration to microservices, and here's three: Netflix, eBay, and Amazon. They started out with giant monoliths, grown over time, then they went to microservices, but not without their pains. They spent a lot of time and money learning a massive amount about the issues they were facing. And several times they would put something out, try something, have to pull it back in, adjust, put out a next microservice, things like that. So their development time was a lot longer than they usually had with the monoliths. But since they decided to still invest in that direction, they made that work for them. And Netflix, for example, they made an open source software library called Eureka out of that development time. So why should you not use microservices? Well, quite frankly, they're hard. I know, and it sounds like a cop-out, but so is good programming. Doing things well still is extremely hard to do, and there's a lot to focus on. So other reasons that you should not do microservices. If the monolith that is you're thinking about not adapting for that new business functionality, if the code base is just too small, you probably don't need to do that. It might actually be easier to have multiple monolith instances and using feature flags to help govern the activities of each of those instances. It's a perfectly fine way of getting things deployed and running, as well as it is a lot quicker to handling things in production than microservices, or developing and getting your changes into microservices. As well, if your code it has too much coupling and it requires a lot of refactoring, you're going to spend a lot of time refactoring your code just to clean things up, regardless of how it works with a microservice. And when it's time to split a microservice from a monolith, you may do a lot of refactoring just to clean up the lines and bring in better uses of dependency injection, for example. And if the development team is unwilling or not ready yet, you're going to face even more battles at the team level itself. Because one of the things you will need to do, depending on the size of your teams, is to actually have devoted teams for the different microservices. And they need to be willing to do what it takes to build and support microservices, including all the learning, such as this talk, and finding all the books, etc., that to help support that. And you need to have a support structure, meaning that for the developers that are developing that microservice, if there's a bug out there, they need to have a support system that is there to help get them the information they need for troubleshooting, to get the bugs fixed and get that next version out. And you've got to be willing to handle the high cost of time and money needed to develop and learn about microservices. So let's go through some challenges as well regarding this. We've got several examples after this that we're going to touch on. So the first expectation, if you will, is that it's going to be rather cheap to do microservices. In fact, it's just the opposite. Like I mentioned, you're going to spend a lot of time and money just learning how to do things. What are the other communication styles that you need? Are you going to do a direct HTTP call to an IP address where you have that instance? What about load balancers? Is RPC, that remote procedure call type communication, is that the one that is okay? Is that the one that's needed? Maybe you should look into messaging. Should you do synchronous or asynchronous type messaging? Maybe publication subscription type messaging model. And try to not think about copying files over to a server for microservices. Instead, you want to set up a continuous integration, continuous deployment pipeline per microservice. This goes back to the fact that microservices are independent applications. And because they are independent applications, they need to have a single repository to house all of that code that is specific to that application. And for the longest time, networking is not really a job of a developer. That's changing because microservices communicate over a network. We need to understand different networking pieces. For example, the OSI model, specifically layers 4 and 7. We're going to touch base on that in just a moment. And as they communicate, we need to worry about the security of that communication. Let's take the example of a microservice that processes not just paychecks, but yours as well. It would be nice to have all of the communications secured by using something like TLS so that the network cannot be sniffed and have that information stolen. And you may think, well, it's a private network and we don't need to do that. But at the same time, you're using a third-party NuGet package that you did not look at their source code. How do you know that a third-party code base is not sniffing the network and trying to send information back out? Take the steps necessary to protect that information. And now that you have that microservice out there and you are protecting it, because after all, it's processing your paycheck as well, it would be nice to control who is able to call that microservice. So using something like OAuth, some other permission model to help govern who can call that microservice. And we've all grown up with the do not repeat yourself, right? If you're copying your code and you see duplicate functionality written over and over, you want to kind of streamline that a little bit. Well, now having common code at the microservices architecture can actually cause your microservices to be tightly coupled. And I have a scenario on that, so we'll talk through that. So touching on networking for just a moment, the OSI model, that Open Systems Interconnection model, is the main one used regarding networking. Physical being, excuse me, like coax, fiber, the copper, and when we plug our routers into maybe a cable modem, etc., it's that physical layer of how bits are getting from one device to another. As they go up the line, the data that's on those lines get handled at different ways. Layer 3, for example, is your IP addressing, ICMP for ping. Layer 4 is TCP, UDP, different types of package. And layer 7 is where your HTTP calls are at. So why do we need to care? Well, if I've got multiple instances of a microservice, but I only have one endpoint for it, let's say I'm going to call it by an IP address. Well, the layer 3 helps get to that instance of that microservice, but it's the data that's on layer 4 that is actually getting in there and getting processed. Load balancers will be used. For example, the Azure load balancers are layer 4 type to help spread that load so that you don't have one instance of a microservice getting all of the load, but to help spread that across. And then you can decide, well, of all the instances of the microservices that I have, even with spreading, they're still getting overloaded, then you can decide how to scale and get more instances. So layer 7, why do we need to care about that? One example of this is looking at the MVC pattern, the model view controller pattern. The one letter that they leave off is R for routing, because as the request comes in and it's coming to an HTTP endpoint, it gets routed to the MVC controller, that controller that receives that data. So the routing is occurring at layer 7. And things like Nginx, is a product that can also use layer 7 routing and even load distribution. We need to understand about those capabilities so that we can help balance the load of all the requests coming into the different instances of microservices. Okay, let's switch gears a little bit. Let's talk about that common code problem that I mentioned just a second ago. Imagine a scenario where team A has microservice A and team B has microservice B, and they're using a internally made NuGet package, not a third party, not something that's available on the internet, but an internal package that the company has. And team A made a change to that NuGet package so that they can get their next version out. In the process, and unbeknownst to the other team, it actually made a breaking change and kept their service, microservice, from evolving and getting to production. So now we have a contention where the changes inside of a centrally distributed NuGet package is now inhibiting the evolution of a microservice of other teams, of other microservices. So how do we handle this? Well, the idea here is that the common code that is allowing one team to make changes and can hurt another one, but yet we're trying to stick to this drive principle, this is where that breaks down. Here, it is okay to copy code and split them out to the microservices that need them independently. So what is happening here is when we say duplicate the code, they're actually not identical for long. What happens as you split out and duplicate that code, it allows that code and that microservice to evolve independent of another microservice. So the point here is to separate the code that changes to their own package for the service that needs it. Okay, quick question though. If we look at that NuGet package right there in the middle, which team owns that? There's a problem right there. So you might be in this position where we've got one or two microservices teams, but all the other developers are working on a monolith and still having this shared NuGet package. You're going to have to split that out and decide who is going to help maintain that. And if it's a shared responsibility, it needs to be very clearly defined as to who does what. So just to recap on this, pull out the code that needs to change and evolve independent of another microservice. And if you still have common code that just hasn't been touched yet, that's fine. You probably will at some point in time. But it is okay to duplicate code to the service that needs it because it's not going to be identical for very long. They'll evolve independently. Okay, so you decide to go ahead and do this, and you've pulled out some functionality out of a monolith and bring it into a microservice, and then you realize, well, it has a dependency on other code, so you pull it over too. Then you have this other stuff that you find that it's also tied, and it has to be pulled over. You just go on and on about it. You realize you actually don't have a microservice, you have another monolith. Now, this is definitely something to avoid, and where you might be okay with this, and I'll explain that in just a second, but you might also look at this and go, wait, we're heading in the wrong direction. Maybe we need to back out and not do this. Or maybe even adapt and use feature flags, like I mentioned earlier, use a feature flags in the monolith so that the instances of that code base is processing different things for different reasons. If, however, you are something like the eBay and Netflix and Amazon did, where they pulled their monolith apart, now they've got two monoliths, and that's a problem if that's your end state. If this is simply a hop on that development road, so to speak, where you're here for now and then you're going to break this up even further, do more refactoring, and they themselves turn into other microservices, then this is fine. You should avoid it if this is your end state. Okay. So one of the things that tripped me up about microservices when I learned about decentralizing data, and I did not like this, having grown up with SQL Server for all of my development career, as well as other databases, but primarily SQL Server. It's a centralized data store. Why break it up? Just have your other microservices call it as need be. When it finally clicked for me as to why that's actually a problem, this is when I come up with this slide in the scenario. So hopefully this helps sell and share the why you want to be very careful of this and go ahead and decentralize your data. And I don't know who, but somebody said that there's this rule that says that a microservice should have its own data store. Well, I'm going to tweak that just slightly and say that a microservice that persists any data should have its own data source. Now, let's go through the scenario and I'll explain why. So we're going to start. Is it strictly necessary to have an RDMS or NoSQL for each? No. And you bring up a fantastic point, and I will touch on that in just a second. So let's start with the scenario where I've got a centralized system, and it has a table for accounts, customers, orders, order history, parts one, shipping history, and logging. And parts one. Yeah. Well, okay. So here's the deal, right? So over time, the monolith changes. The parts table also changes. The schema of that table changes. And now we got to some point in some change that it just didn't make sense that we were going to break things. So what we did instead is we made another table for parts to handle the differences. And well, naming is hard. Surely I'm not the only one that's ever done that. So now we have parts one table. That's bringing up the point that schema changes on the tables. They have to change because the business logic is changing for the business needs. So now we're going to develop a microservice for parts and microservice for orders. And we still have our monolith. And now we're going to go even further and have a microservice that's also for shipping. And you realize that the data stores for the microservice should be the single source of truth of that data, meaning that the microservice for parts is the only system that holds the parts information, sort of. Now, and to bring up the question said just a second ago, when you decentralize your data, and just as you have microservices and you get to choose the best programming language for that microservice, you can also choose, depending on your business needs, to choose the type of database for that microservice. So let's take in this example that maybe the shipping and the orders microservice, maybe they're NoSQL. Maybe it's DynamoDB, something like, or Cosmos DB, something like that. And where parts is still a relational database, so SQL Server, Postgres, something to that effect. Since they communicate across a network, that allows that opportunity to change even how your data is stored and structured. So now that I've got a parts microservice, and it is the single source of truth of everything parts, and an orders microservice, that is a single source of truth of all things orders, and shipping and just the like. Well, orders needs to have information about parts that belong on the order. Shipping needs information about orders that go on the shipping information. And how does transaction work across multiple tables? We're going to get to that. You're just a couple of slides ahead of me. We're going to get to that. I appreciate these are great questions. So here, we're saying that a microservice has everything to do with shipping and orders and parts, but they need information from other microservices. Fine. Okay. So a microservice can do a network call. It'll just call the other microservice and say, hey, I need this information. If I'm requesting something from the orders microservice to pull up an order, then it has to pull up the parts information that goes on that order, and then it's returned to the caller. This is fine. That is a suitable scenario if you need to. You may also find that when microservices are calling other microservices for those reasons, depending on what your business scenario is, then your calls are very chatty. So if they are chatty and you're now getting more latency, and that's not really tolerable in your scenario, then the suggestion is to actually copy data, just like we're talking about copying code. Now I'm trying to tell you to copy some data. That sounds bizarre, right? You got a microservice that's the single source of truth of everything parts. Why would I have copy in the orders table? Let's go through this for just a second. So the parts data store here has everything to do with parts. It has all this information about, from the ID to the color, the container, the manufacturer, what part number it replaces, when was it discontinued, etc. Right? This is all that schema level stuff about a part. Well, when I say copy information from one data store to another, what I'm really referring to is that for example, the orders microservice has information about a part, but only enough information that is suitable for the business needs of an order. It doesn't need to care about the replacement part number or when it was discontinued and stuff. So the idea is that I have a little bit of the data that is copied between the data stores, but only enough to fulfill those business requirements. And now somebody's about ready to type this up and send this in, so hopefully I can jump ahead of this. Well, now that I've got data duplicated across multiple systems, how do I keep them in sync? And how do we handle transactions? Certainly if they're in two different data types. That's where we may say, well, let's consider a different messaging style. What if we did a messaging bus? So let's go through a scenario. We have a monolith that's hosting a website. The administrator goes in and adds a brand new part to the system. She fills out the information on the form, hits enter, right, submits that change, and a message then is sent directly to the parts microservice, and it adds that information to that single source of truth data store. And then let's say that somebody notices, well, I'll tell you what, I'm jumping ahead. So now let's say that somebody is going to go and order that part. So they're on the website, standard user coming in, they find what they want, they create the order, submit it, make the payment, etc. So now we have a message coming in that says, all right, great. I need to go and create a order based on that. And so it's going to create the order out of that microservice, and it's going to pull information about the part that it's selling. So it has just a little bit of that copy of just enough information into that microservice. Great. And then shipping is told of it. It pulls inventory and sends it out. And then somebody tells the administrator, oh, by the way, there was a typo in the part name. There's a small typo in that. Okay, so the administrator logs into the system, finds that part, fixes the typo. Notice that the activity is different. This is not a new part message. This is an update part information message. So that type of message is then sent out, and both the parts microservice picks up that message, reacts to it, finds that part item in the data store, and updates, then fixes the typo. but also the order microservice reacts to that same message. So it looks through and says, yep, sure enough, I have orders with that part, and I will update the text just on the name for that. The idea here is that the business action of updating information, you get to decide how it is to be reacted on individually. Is this a direct message from one instance to another, or is this maybe a pub sub type message? That's up to you, depending on the business needs you're trying to fulfill. Updating a typo means I've got two microservices that need to react to that and update their data accordingly. So now let's go one more step further on messaging with a different message type called a saga. And now the microservices changed just slightly for this scenario. Excuse me. Something that I do in real life is that I have a separate checking account and there's $200 in it. And I use that checking account for any purchase that I make on the internet. Therefore, if it's ever hacked, the most they're ever going to get is that $200. It's a great idea because it's not where my paycheck lands, right? So that's in a different account. So now what tends to happen from time to time is because I'll forget to put some money in there, is I'll go buy an item. Let's say I bought a $150 item, whatever. Now I'm down to $50 in balance. And then I go and buy something for $75. All right, so let's think of that scenario. So I go to this website on the hosted by the Monolith, and I find what I want. My cart is full, and it's $75. And let's think about what Amazon does in this case. So an order is created. I get an order number. I get an email saying thank you for the order, right? And information in this saga type message is also sent to the payment microservice, and it says, wait a minute, the payment failed, insufficient funds. Oh, okay. What happens then is I get an email a few minutes later. Notice that the order was created, but because the payment failed, the saga information changes. The order microservice picks up on that, says, okay, then we're going to change the status of this order. Notice that we're not going to delete data. We're going to change the status on this order. We're going to change it to maybe payment pending or some flag, right, that says this is why we cannot fulfill the order. And also an email is sent to me saying, by the way, the payment failed, not enough funds. Okay, sure enough, I go move some money over there, go back to the website, let's say reprocess that again for me. Saga is updated, payment microservice reacts, sends the payment information out, processes it, says it's all good. Fantastic, updates the saga for this order. Shipping can now react to that, pick the item, and get it sent out. So different message type depending on the needs of what I need this system, the architecture to communicate with. So back briefly touching on transactions, you can use sagas to help across multiple tables. Now, I'm saying, and just because this is a very quick demo, is that a microservice has a data store. There are some people a lot smarter than me that will suggest you can still have that centralized data system, that data store, but you will find schema contentions at some point with your microservices sharing and pulling information out of that one data store. At some point, you want to break that up. Does it have to be a separate database? Actually, no. It can, that's one option. It's probably your best option. Just depends on your needs. You could also have a schema level and the database. So SQL Server and Oracle, for example, just picking two, support schemas, DBO, right? If you're familiar with DBO in SQL Server, you can create other schemas. Meanings that you can change the permissions at the schema level or even at tables at the table level so that this system cannot talk to that table or store procedures or functions, except for this other microservice that is logging into that system by a different account and has different permissions. That's going to be between you and your DBAs to work out, and DBAs are not fans of more work to do, so they're not likely to go and add more databases. But at the same time, think of it this way. What if that monolith database has tons and tons of data in it, but the shipping database may have a fraction of what size of another one? Again, it goes back to what your business needs are. I'm pointing out that you have different type of communication options. You can do RPC, the direct, make an HTTP REST-based call to an endpoint through a load balancer. You can do that, and or, depending on your needs, use messaging. Something like mass transit sitting on top of RabbitMQ, for example. Okay, we're going to switch gears. And let's talk about decomposing a monolith to microservices. Now, this is going to be really quick because, again, this is one of those things where there's so much to this. When we talk a little bit about domain-driven design, we could do a workshop. We'd be here all week. There's just so much great stuff to handle through that. So it's going to be really hard to do in just this one session. So there will be high level. So the idea is that with decomposing a monolith to a microservice, you're going to extract functionality out of a monolith and bring it into its own microservice. Now, I don't know about you, but I have never worked on a monolith with code so cleanly separated from everything else. It's been usually things like this: blurred lines, lacking good dependency injection. You can't just replace classes as needed very easily. So you're going to have to clear those boundaries. You're going to have to spend time refactoring. You need to find good good places to use dependency injection so to help make objects interchangeable and become loosely coupled instead of tightly coupled. All right, so I'm going to cover a question that I get all the time. How should I get started? All right. Start small. What does that mean, start small? Find a smallest piece of code that you can pull out. It may not even be the code base that you really want to move over for your first production microservice. But here's why I say start small. You have to spend time learning how to do this, right? You're going to be finding some books by Sam Newman, Martin Fowler, etc. But you also have to build that infrastructure. Since they communicate over a network, you're going to have other servers set up. You're going to be able to manage the other instances of microservices, understand what load balancers you're going to put in place. And because I keep stressing this, microservices are independent applications that you need to have and be able to deploy them individually from any other application. So you're going to want to set up your CI/CD pipelines as well as your code repository. All of that has to be built regardless of the size of the microservice, so you might as well start with a small piece of code, something very simple. Then, as you're picking away with it, you'll understand a little bit more about how to set up that infrastructure and to get started and get moving. Okay.
I had a quick question for you, Sean.
Yes, go ahead.
Would you be able to have a cloud provider, maybe like Azure or something, help you with some of that? Is there? I imagine that there's money to be made there, so I'd imagine that a cloud provider would be able to help with some of the infrastructure you just mentioned.
Yeah, absolutely. You can use something like Azure Kubernetes Service, AKS. That's actually where I got my start with Kubernetes, was with AKS, and we were hosting the microservices on it. And we used the load balancer that was built in. And so there was even a learning curve just with the Azure Kubernetes side of things. And I will say it's much easier to use AKS versus spinning up your own Kubernetes instance. But also things have improved since a few years ago when I was last doing that. So yeah, absolutely. You can use even in AWS if you're going to use Lambdas and you're controlling that focus of that domain of what it's really doing, then you might be able to consider that a microservice. It's communicatable over a network technically, and you can control the permissions with that. In Azure, you do Azure functions. Certainly as well, with SQL Server, Azure SQL, Cosmos DB, etc. So absolutely. And then if you need to spin up virtual machines, of course, right? You can set up a virtual network, set up a few virtual machines. Given a lot of what I do on my day job, I have to control certainly as to who has access to it. For example, I have the access to create virtual machines. I do not have access to access them. That's somebody else's job, but that's also because of data protection. So, as well as the governing the network, who has access to be on that network, etc. So, absolutely, cloud, absolutely, easily be able to do it. I don't have much information about GCP, but of course, yes, absolutely, you could do it there as well. So hopefully that answered the question. But that was also one of the reasons why I mentioned Azure Load Balancer earlier. Super easy to spin up an Azure Load Balancer, and they work on layer 4. If you're in AWS, you've got the Elastic Load Balancer and Application Load Balancer. A network load balancer is TCP versus an application load balancer that is HTTP only. So you want to look at what are your restrictions for what you need, given how you expect these to communicate. And just because you have a microservice sitting on an instance anywhere does not mean it has to be port 80. Does not mean it has to be that at all. So it definitely opens things up. I would also highly suggest looking at for internal communications, maybe microservice to microservice, using gRPC. Depending on your latency and what problems you may be trying to fix with that, look into gRPC. Help speed up some of that communication. Okay, so switching back to an example for decomposing a monolith, let's, will someone use Lambda or Cloud Functions over Kubernetes container clusters or vice versa? I will tell you that I do a lot more with Lambdas right now than the AKS or the EKS. When you have, there's a lot of pros with Kubernetes, but it's also another system that you have to be able to manage. So there's also that learning curve there. And being good stewards as we are, we need to make sure that we're not the only ones that know how to do things. So you also have to have a team that is knowledgeable of Kubernetes and be able to understand the differences between the load balancer options that you have, the pros, the cons, etc. Should you use Helm, for example? Using Lambdas are actually a lot easier. There's no virtual machines that you have to worry about. There, you don't have to node count. So it just depends. So on what you need. If you need a heavier code base that's more than a single entry point that Lambda provides, you might look at something like Kubernetes. So there's several options out there. And I can tell you one of the things that I've done is I went down a list of items and spun up different ways, try to solve a problem in different ways and see which one was really going to benefit us the most, which one was easiest for us to work on, build up, and maintain. So, excuse me. So hopefully that answered that question. I'm moving stuff around. Let me get caught back up here. Okay. So with our fake company here called Wham Bam, they make fidget widgets. And looking at domain-driven design, we noticed that they are a production company. So they have a production domain. Their main domain, which is going to be the main area for the focus of business logic, is in this main domain for production. Now, domain-driven design is fantastic, but it's also not the only way for to do decomposing monoliths to microservices. It's just the way that I'm kind of working with in this example, but there's several other ways out there. So, like I said, with Wham Bam, they're a production company, and their main domain is that production. Now, they have secondary domains for purchasing and shipping, because they also need to be able to purchase raw material and give that to the production area for them to assemble the various parts together to come up with a final product to give to shipping to get it out the door. And then there's also the other domains, the generic domains for maybe third-party integration, inventory, account handling, invoicing, returns. The generic domains are more for something like you would replace with a off-the-shelf application if you can, meaning that this is a production company. It's not a hospital. It's not a healthcare. It's not a insurance type processing type of system. So that main domain is really dependent on the purpose of that application. Now, to help better understand where your domains are, something that I highly suggest is looking at a thing called event storming. Now, this is different than event sourcing, entirely different, but event storming is a workshop-based activity developed by Alberto Brindolini, and you can go to eventstorming.com to get a lot more information on this. But the idea through this workshop, so imagine that you're in a hallway and you've got large piece of paper, very long piece of paper going across the wall. And you have a lot of sticky notes, but they're color coordinated. So you've got 5 or 6 different colors for for the different pieces of event storming activities. So you're going to have a color for your domain events. You're going to have a different color for your actors, different color for your aggregates, which we'll talk about in just a moment. And then even maybe the red sticky notes, and this is to highlight questions that nobody has the answer. But who's putting this information on the wall? This is a workshop for us developers to get with the subject matter experts, or the domain experts, so that we can start putting things on the wall and highlight things using the sticky notes as to how is an invoice processed, or how is an insurance claim handled. And in our case, how is purchasing done? How does that purchase part go into production? How is that assembled? What is the code that has to handle that and be able to manage that through that process? So you go through that workshop and you're able to see that on the board with all this activity, and you see the functionality, the things that are very common to each other, and you can see the different areas. Now, I say areas, so if we look at different functionality as to what's going on in the system, we can see that, well, we've got code that handles vendors. We've got code for handling the parts that they purchase, as well as we got code for handling the parts and the orders and the products, the final products, in the other area. So what you notice then is you can draw these circles around the common areas and go, okay, these are our bounded contexts. Over here is purchasing bounded context because it's vendors and the raw material that they're buying. that the purchasing department is buying versus the functionality over here for taking that part, turning it into taking it to other assembled parts, putting them together to become a final product and fulfilling that order. So you're noticing that you see these business functionality groupings and you could draw your circles around that, and that's your bounded context. One of the things you noticed is that we have parts and parts, but they're not exactly the same thing. It's not the same code, and it just happens to be the same name applied in two different areas. In domain-driven design, one of the main tenets of domain-driven design is a thing called ubiquitous language. The ubiquitous language is when we change things, change the names of things so that it is less ambiguous and is more specific to what we're really talking about. So if I talk to anyone in the audience here and say, I'm referring to the purchased parts, you know exactly what I mean, versus the assembly parts, which is the actual other parts of the assembly going through the process before it becomes a final sellable product. The names are more specific to their purpose. As well with ubiquitous language is the suggestion that in our code that we also be very careful of the namespace, the class names, and the method names that we use when we do this, when we develop our code, so that we have and work with that ubiquitous language. And by doing that, it helps alleviate a lot of that confusion. Okay, one of the things that I'm going to do now is I'm going to jump a little further into this production bounded context. So now inside the production bounded context, I have things called aggregates. Now we're talking about class names. And one of the things that I see is I have a class for order, and an order is created of multiple order lines. And there's functionality there. But as well, a product has assembly parts. So there's a class for handling the functionality of handling and maintaining the data for a product, as well as the functionality in the assembly parts. So the idea here is that you see the dependencies. And when you see that dependency clearly defined, those are called aggregates. So we have an order aggregate and a product aggregate. We can go one more step further and we point out that the order, which is the top level class, and the product being a top level class, those are the aggregate roots. With domain-driven design, the rule is that any code in an aggregate can call another aggregate as long as it calls functionality at the aggregate root. If the functionality that you need is not available at that aggregate root, then you go and get with that team, if it's not you, to go and make that functionality available at that level. Why? If I've got code in order line that executes code over in assembly parts class and it changes data, you risk the data integrity. Then the product and the other, that instance of that class may not be aware of what's going on. By exposing that functionality at the root, it can help keep things and keep that data integrity all the way down. Obviously, in my example, it's it's overly simplistic. I got one class of order, one class of order line. There's always a lot more to it. So now that I've got functionality exposed at the aggregate roots for order and product, maybe we're at this whiteboard, the virtual whiteboard, and we decide, you know what, we could, because of so much common functionality going here, we could go ahead and put that into a microservice. And that microservice is then exposing the functionality of the aggregate roots at the point of a network. So the idea here is, and this is, again, it's a very high level and a contrived example, but you can have a microservice that is now with that bounded context. As well, a microservice can have more than one bounded context in it, depending on what your business needs are, as long as the focus is tightly controlled. So be very careful about adding additional bounded context unless it's absolutely needed. One thing that you will not have, or so I should say, should never have, is a bounded context is shared across two different or more than one microservice. Now, keep in mind that everything I'm referring to here so far is regarding business logic. There is a case where you will have a bounded context that is shared across many microservices, but it's not about the business logic. And that would be for cross-cutting concerns. So as you're developing your microservices, you realize that you need to capture metrics and logging and monitoring of the stuff that's going on. How do you know if a microservice instance is healthy? You need to be able to capture that information. You may use again, it's not about the business logic, but it's about what you're capturing. And maybe you're using something, and I've already agreed to use something like Log4net or Sumo, right? Sumo Logic, and maybe New Relic for capturing your metrics. Maybe it's Prometheus and Grafana, or CloudWatch, for example. It's less about the business logic and more about the cross-cutting concerns that help support the health of the microservices. All right, time to finish up. Let's do a quick review. Microservices are hard, but so is good programming. They require a lot of analysis and good teamwork to work together to help define these. Don't be surprised if you develop a microservice and then you start over, or maybe even get it onto production and still have to pull it back and refine it a little bit. They're going to take time. They do provide that team autonomy, allows that team to choose the right programming language for the job to help better support that microservice. And microservices can be autonomous from each other. So the human resources type microservice can be deployed independently and evolve independently of another microservice. And it also provides scalability. It allows you to choose different types of servers, different size servers, depending on your needs. And it also helps to provide that fault isolation. So if you do have a microservice that is failing, other business processes can still continue. But they are very costly in time and money while you're learning and investing on how to get this developed and how to get that code moved over and to grow from there. You do need to decide, because it's over a network, what is your communication like? Are you going to use messaging? Are you going to use an RPC style REST-based, HTTP-based type communication? Maybe you're going to use PubSub on some of the message types, maybe Saga on a different one. And because, and again, I'm going to stress this, that microservices are independent applications, they need a CI/CD pipeline and a code repository per microservice to let them evolve independent. And remember that sharing code can keep your microservices tightly coupled to each other. Got to be very careful of that. And yes, us developers need to start learning a little bit more about networking and how things actually work in a networking environment, specifically about layer 4 for layer 7 as it regards to load balancers. We also need to worry about securing that information and governing who is calling that microservice. So we also touched on domain-driven design. Again, not the only way to do it, but a good way to do it. It lends itself really well for this in the development of microservices, because when I say a tight domain, it's referring to domain-driven design. And helps to understand what your domain is. And as you go through that and you're realizing there's so much more functionality here than we were planning, maybe you need to split up that domain even further, even if that means a different microservice as well. Some recommendations that I have are the Microservices Patterns book by Chris Richardson. the domain-driven design book by Eric Evans, the guy that created domain-driven design, and Patterns, Principles, and Practices of Domain-Driven Design, PPP of DDD, by Scott Millett and Nick Toon. And I will say that that book helped me the most wrap my head around domain-driven design. They have a lot more examples that really help solidify some things for me. All right, last little bit about me. My name is Sean Whitesell, president of the .NET User Group in Tulsa. And I am a Microsoft MVP. I'm also a cloud architect. And on occasion, I am on Twitch, not as often as I would like to be. But when I get a chance, I am on Twitch as Code with Sean. So come see me, come say hi. And thank you all for being here. And if you have any other questions, you're more than welcome to pop them in the chat. And I'll be here for a little bit and we'll get them answered. Kellen, thank you for having me.
Yes. Thank you for being here. Thank you for sharing your knowledge, your work, and your wisdom, giving us a lot of good information to work with. And as always, one of my favorite parts is just how quick and interactive you are with the chat base. So I always love to see that when I'm working with people. So I'll just make a quick announcement here. We'll be having kind of an after hangout. I'll post a link here in the chat as the music plays us out and everything. And then I'll also post it on the meetup event page. That way anybody from the San Antonio group or the .NET virtual group, we can hang out and meet each other for a little bit, kind of in an informal capacity. So, and that's all I have for this one. So I guess we'll send it out and wrap it up unless there's any questions there in the chat. I'm not seeing any. Okay. Thank you, everybody, for coming out.